In week 1, we talked about algebraic expressions as being a collection of terms. We defined terms as a number or the product of a number and variable or variables raised to a power. We also defined polynomial, monomial, binomial, and trinomial. We said that a polynomial is a finite number of terms. That means you can count how many terms there are. And specifically, a monomial had one term, for example, 3xy cubed. A binomial had two terms, for example, 5x squared minus 7y. A trinomial had three terms, for example, 8a squared b cubed minus ab plus 4. Every time we add and subtract, we have a term. Each one of these terms is a monomial. Now, one of the things that we talk about more in Math 103 than in Math 99, but a good idea to get used to here, is the degree of a polynomial. Now, we're going to only look at a polynomial in one variable. So if we're looking at the degree of a polynomial with one variable, that's important. It doesn't have more than one variable. We're going to say that the degree is the highest power. So when we look at this example below, we could see that we have a trinomial. There are three terms, and 3 is the highest power. So this is a trinomial of degree 3. In week 1, when we first introduced algebraic expressions, we talked about adding and subtracting like terms. Remember that like terms have exactly the same variables raised to the same exponents. This is important. We keep the variable and its power, those don't change. We add and subtract the coefficients. So when we're adding, we can ignore the brackets. Now, ignoring the brackets meant I had this plus minus beside each other. We said in week 1 that that means we can say we're just subtracting. We can only add and subtract like terms. So we have some x squareds. We have some x to the power of 1. And then, of course, our integers. If you like, we can rewrite this so our like terms are beside each other. But you don't have to do this step. It does make it a little bit easier to see. Keep the x squared, subtract the coefficients. Keep the x. This gives us 0, so I don't need that at all. And then 5 plus 5. Negative x squared plus 10. Or we could say this equals 10 minus x squared. That works as well. When you're subtracting, you have to distribute the negative sign It's like multiplying by -1. Using the distributive property. That means the signs in the second bracket change. So we can't just ignore the brackets. Now we have minus -3x squared. That gives us plus 3x squared. Minus 7x. Minus 5. So notice that the signs changed. This negative became plus. This plus became minus. This plus became minus. Now we can combine our like terms. And again, you don't need to write this step. We have 5x squared minus 14x. Why don't you try one on paper? Pause your video. Solve this expression, or rather simplify this expression. You see I've opened the brackets and I've changed the signs. This positive 7x squared became negative. This positive became negative. This negative became positive. Now we can combine like terms. And you should have finished with minus 4x squared minus 5x plus 7. The next two examples here are vertical addition and subtraction. They're up and down on top of each other instead of side by side, horizontal. Now, vertical addition is actually really nice because we have our like terms beside each other. So we don't have to move anything around. We can just look at what we have and simply add. We have 6x squared, 0x's, plus 2. But the one I'm especially interested in is the vertical subtraction, because when we start looking at the long division of polynomials, we will use vertical subtraction in every question. So just like we said for the other subtraction, the signs have to change inside the brackets. So our first expression stays the same, but we end up now with minus 2x squared plus 3x minus 4. Once we open the brackets, we can simply add like terms. So you see we have 2x squared plus 6x minus 6. We don't want to have to rewrite that question every time. Let's take a bit of space here and try another one. Pause your video, do the subtraction. What I would like to see you be able to do is, rather than rewriting the question, is just change the signs inside the brackets. And now remember, all we're going to do is add the like terms. So 3x squared and negative 5x squared is minus 2x squared, minus 5x minus 6x minus 11x plus 11. Did you get that? Remember again, you can always go to the homework assignments in Pearson if you want more practice with any of these types of questions. We'll just talk about multiplying monomials today in this last lecture before we go any further. And we've already done some monomial multiplication when we first talked about the distributive property. So we need to remember our rule for multiplying with exponents. The bases are the same. Keep the base and add the exponents. That rule is going to be important. But when we're multiplying monomials, we want to remember that we're going to multiply the integers and then multiply the variables with the same base. So we have 2 times 3 is 6. X cubed times x squared, keep the base, add the exponents. Let's look at the next one. Multiply the integers, multiply the powers with the same base. Negative 4 times 2 is negative 8. Keep the base, add the exponents. Why don't you pause your video and try the next one? Multiply the integers. 5 times negative 5 times 2. Well, I have an odd number of negative signs, so I know it's going to be negative. 5 times 5 is 25, times 2 is 50. Now I'm going to multiply my powers with the same base. Keep the base, add the exponents. Pause your video again, try this one. We're multiplying the integers. 2 times 3 times negative 1. We have one negative sign, so we know our product will be negative. 2 times 3 times 1 is 6. Now we want to multiply powers with the same base. So first we could multiply our powers of m. Keep the m, add the exponents. 3 plus 1 plus 2. Then we can multiply our powers of n. N squared times n squared times n cubed. Keep the n, add the exponents. Did you get this answer? Take some time before going on to the next video lesson and do some practice either in your quizzes, your homework, or your e-textbook.